parts about the quiz is about electrochemistry, where we should know the basic rules of oxidation numbers. Now, definitely a periodic table will be given to you. So from the periodic table, you can know the oxidation numbers. But however, there are some rules that you need to remember. Any element given as a free, like oxygen, hydrogen, iron, aluminum, any compound given to you as freely in the equation or in the question, the oxidation number will be 0. Ions, if any ion, monoatomic ion is given, the answer is written on it. It's the charge. Fluorine in compounds. I'm not talking about F2. F2 oxidation number is 0. But fluorine in compounds like NaF or OF2, F here is always -1. It's fixed. It doesn't change. No exceptions. Oxygen in compounds is always -2. Like for example, in H2O, it's -2. In CO2, -2, etc. You will see the examples that I will give later on. But oxygen in peroxides, and here's the peroxide, is H2O2. O is -1 and not -2. Just memorize this. For you to know, there are other exceptions for oxygen, but I'm not mentioning them. They're not included. Okay? And it will not be given to you. Hydrogen, always +1 in compounds. However, in metal hydrides like, for example, NaH, KH, LiH, anything from group 1 and hydrogen or group 2 and hydrogen, MgH2, calcium H2. In this case, hydrogen oxidation number will be -1 and not +1. Now, the rest of the rules, 6 and 7, we use this rule in order to determine the oxidation number of all the other elements that I did not talk about. Now, in compounds, metals of a group 1. So here's the periodic table. Okay, so we have elements of a group 1. We have metals of group 2. Let me just change the color. So metals of group 2, and we have those of group 13. They have a fixed oxidation number of +1. Metals of group 2, +2. I'm talking in compounds. And of group 13, +3. In compounds, those are fixed. And here Mg is +2, fixed. K is +1. Okay? So if I have a compound and I don't know the oxidation number, I'm going to take those examples later on. You can use the concept of group 1, 2, and 13 to have a fixed oxidation number in compounds. The sum of oxidation number in polyatomic ions, it's the total is the charge. So here I have, a second. So for example, in MnO4, the total is negative. So MnO4 minus. I don't know the manganese, but I know the oxygen. So it's unknown, Mn plus 4 times the oxygen equal -1. So the Mn is equal to +7. Now, on my channel, there is a video that I sent it already to you. I shared it with you. and it's only to explain the oxidation numbers and how to find them. So please, if you have a difficulty in the oxidation number, go back to this video. Now, which of the following correctly lists the oxidation states of chlorine in two compounds? So I have two compounds, an AClO4 and I have an ACl. And I need to know the Cl every time. Now I'll start with this one. This is easy. The Na belongs to group 1 from the periodic table. So Na is positive 1. Therefore, Cl is negative 1. Now, again, O is negative 4, and this is positive 1. So plus 1 plus x plus I have 4 times the O times negative 2 equals 0. X is plus 7. So that's the oxidation number of Cl in these two
Yes.
compounds. Yes.
We said 0 لأن there is no any ion in the compound, صح؟
Hon. Yes, this 0. Yeah. An AClO4 neutral هون nothing is written. مثلا MnO4 هون في minus. هون you don't have a minus, so it is equal to 0. That's rule number 6. The sum of oxidation number in a neutral compound, it is 0. The sum of oxidation numbers in an ion is equal to the charge of the ion. So this is why Honi, when I solved it, I said equal to negative 1. And here, when I solved it, I said equal to 0. Okay? Now, let's move on. Which of the following species has the highest oxidation number of sulfur? It means that I need to get the oxidation number of sulfur in every given compound, in every given choice. Here, this is a free element, 0. Now, in all these cases, oxygen is negative 2 by the rule. So let's start with A. X plus twice the oxygen equals 0. So X is positive 4. In B, X, I don't know the S, I'm going to call it X. Oxygen is negative 2. However, I have 4 oxygen and it's a negatively charged ion. So instead of saying equal to 0, I'll say equal to negative 2. Therefore, here X is positive 6. So A out or E out لأنه I found one higher. C, X plus O, which is negative 2, 3 times equal negative 2. So X is plus 4 out. D, okay. In this case, I have 2S. So I'm going to say 2X plus 4 times the oxygen, that each one is negative 2, and equal to negative 2, the overall charge. So here, 2x is equal to 6, x is equal to 3. So this is a very good example that can give you a practice on how to calculate the oxidation number. So the one that have highest oxidation number is B. Moving on. In which of the following pairs of compound the oxidation number of nitrogen in the ion is higher than the oxidation number of nitrogen in the compound. So this is an ion. These are the given are compounds. They want us to choose the option where N here has an oxidation number higher than the N in the compound. So we need to find out N in every example. So I'll find N for the first one. H is positive 1. So I'm going to solve this here. X plus 4 times the hydrogen, where each is positive 1, equal the charge, equal positive 1. Therefore, N over here is equal to negative 3. So here N, I found it to be negative 3. Now, let me check the second one here. In this case, I have 2 unknown. So it's 2x plus 4 times the hydrogen. Each one is positive 1. And this compound is a neutral, so it's equal to 0. Therefore, solving this, x is negative 2. Negative 2. So, is the ion higher than the compound in this option? No.
No.
So, 1 is out. Next, NO3. Again, N is X plus 3 times the oxygen equal the charge. So X is positive 5. So it's plus 5. And in here, 2x plus 4, the negative 2 equals 0. So x is positive 4. Okay, so positive 4. Okay, this one we can take it as an option because the ion has an oxidation number higher than that of the compound. I still need to check the last one. So for the last one, I have X plus twice the oxygen, negative 2, equal negative 1. So X is positive 3. And for this one, 2x plus minus 2 equals 0. So 2x is 2, x is 1. So again, the ion is higher. I hope that this question is clear. So the answer is the second and the third. Any questions for this one?
No.
So this was my way to give you more practice on how to find the oxidation number. Now, the oxidation of chromium. K belongs to group 1. I have 2K plus 2 unknown plus 7 oxygen. Each one is negative 2. The total is equal to 0. So X is going to be, so 2x minus 14 minus 12. It will be 6. D. The oxidation number of an A in NSO4. I don't need to solve it because an A belongs to group 1. It's a metal. In compounds, it's positive 1. Oxidation number of Fe in FeNO3, 3. I can solve this I can think about it in so many ways. Seeing number 3 here means that this is the oxidation number of Fe, and Fe is plus 3. Or, knowing from the previous lessons of acid and base, HNO3, when it ionizes, it gives me H plus, and it gives me NO3 minus. So I literally know that this part here is -1. So I can like say FeA3, and Fe is X, and A I have 3 times and it's -1. So Fe will be +3. Pause and repeat the video if this part is not clear. Now, oxidation number of Br in this one. And A belongs to group 1. Br is X. Oxygen, I have 4 equal to 0. So it is +7. C. Again, I think I did KMnO4, no. So the oxidation number of Mn, we did it first when I gave you the example of MnO4 minus. Now, if it's the same, if there is K, still the same, K plus 1, Mn unknown, oxygen -4 equals 0, X is +7. Oxidation number of hydrogen in compounds is always +1 except in metal hydrides, and that is not a metal hydride. Oxidation number of P, so that's an X plus. I have 3 times oxygen. Each is -2 oxidation number equal to -3. So X is +3. NO3 minus, N is unknown. Again, 3 oxygens, each one is -2, and that is equal to the -1 over here. X is +5. Free element 0. Oops, typing mistake. So it should be 0. The oxidation number of N in NO2. Again, we just did it in the previous example. I'm just going to write it again. 2 -2 equals 0. X is +4. Okay, now, why do we need to know and learn about the oxidation number? Knowing the oxidation number, knowing the oxidation number.
Miss, this is the
Yes.
second lesson.
لا لا بعدنا still in the first, but this is a question that I added that will also be part of يعني I need it. يعني oxidation number is basic lesson required for topic 7 and 8. You cannot work without oxidation number. Okay? So knowing the oxidation number of atoms on an equation, it can help you know whether that substance, that atom / أو ion did an oxidation or a reduction. لأنه we need to know, we need to learn how to use the oxidation number to answer the questions later on, which species oxidized, which species got reduced, etc. So oxidation means loss of electrons. يعني I can know that this atom lost electrons or gained electrons. Gain electron. How? If the oxidation number oops, increases, like for example from -5 to -1, that's an increase. Oh, from -5 to +1, or from +2 to +3, or 0 to +2, that's an increase. If the oxidation number increases, it means there's an oxidation taking place. So you will say oxidation. And if the oxidation number decreases, like for example from -1 to -3, or 0 to -1, that's a decrease, or +3 to 0, that's a decrease, we say that the substance got reduced. Reduced. Okay? And we will see this in the coming examples. So, define oxidation. Oxidation is the loss of electrons. When a substance loses electrons, the oxidation number increases and it becomes, and it is called a reducing agent. Okay, so I'm gonna, so it's when a substance loses electrons and increase in the oxidation number, and increase in the oxidation number. Um, Also, I can define oxidation by saying that the substance, instead of saying loss of electron, I can say or loss of hydrogen or gain of oxygen. Like, for example, if I have, I'm just going to try to get the examples I gave you before. So if I have a reaction, I need some space here to write it. I'll put the definition of reduction and then I'll give you examples of loss of hydrogen and oxygen. That would be better. So define reduction. It's when a substance gain electrons and decreases in the oxidation state. Oxidation number. And it is called oxidizing agent. Now, it is a gain of hydrogen or loss of oxygen. So that's how I can define it. So I'm going to give you an example. Okay? So H2S plus Br2 gives HBr plus S. Now look at this substance. It lost the hydrogen. So this one is showing loss of hydrogen, means oxidation. However, Br2 now it's with HBr, gain of hydrogen, that's a reduction. And I say that B2 got reduced and H2S got oxidized. Another example to show loss and gain of oxygen. So if I have calcium plus zinc oxide, now I'll get calcium oxide plus zinc. So look at this one. Ca gained oxygen. So Ca undergoes an oxidation, gain of oxygen. And ZNO, no more O with the Zn, so lost the oxygen. We say that ZNO got reduced. So ZNO got reduced, Ca got oxidized. And I don't prefer to look at loss of hydrogen and loss of oxygen because I cannot use it all the time. What if the equation doesn't involve oxygen and hydrogen? Sometimes it involves and it's not clear. So it's always better to watch the change of the oxidation number, if it's increased or decreased, and better to see if the substance lost or gained electron. Like this, you'll be on the safe side. But we still need to know the definition in case we were asked to write the definition. Oxidizing agent. Oxidizing agent is the substance that gets reduced. Is the substance, it's not writing, it's the substance gaining electron and reduced, getting reduced. What is the reducing agent? It's the substance losing electrons, and getting oxidized. Losing electrons and oxidized. I hope that this is clear. What is an oxidation half reaction? How do we write it? So if I have a substance, let's say Fe2 plus, that turned to Fe3 plus. In the oxidation, see the oxidation number increased. So this is an oxidation. I know ahead that electrons are written after the arrow. But also in class, I taught you that you count the charges, like this is a 3 and this is 2 plus. So you add electrons to the side that is having a higher charge. So this is a higher. Now I want to lower the 3 to 2, so I'll add 1 electron. I'll give you another example. If I have, let's say, N2 and no, N3 minus. Okay. Now I'll mention later on why this is a reduction. Wait, I'm going to give another example of oxidation. Let's say I have O2. No, not O2. Cl. I need to show you something increasing, like Zn2 plus. That's increasing. So the oxidation number here is 0, turned to positive 2. So this is the higher side, so you add electron on here. So in conclusion, for an oxidation half reaction, you always see the electrons written after the arrow. What is a reduction? It's a gain of electrons. So I have Fe3 plus going to Fe2 plus. The oxidation number now is less, so I write the electron here on the higher side. Or for example, Cl2 going to Cl minus. I have a 0 and it is negative 2 because I need to balance the atoms. So Cl2 and 2Cl. So here's the higher side. I need the 0 to drop to minus 2. So I add 2 electrons. So in conclusion, in a reduction, electrons are added before the arrow. We continue. Identify, this is a typical question. Identify what's oxidized, what's reduced, oxidizing agent and the reducing agent. And in order to answer this question, that's why we are learning the oxidation number. Free element, it turned 2. I can stop here. I know now the answer. Or I can check the Cu 2 plus and 0. The zinc oxidation number increased. So the zinc, this one, is the one oxidized and it is called a reducing agent. And if this got oxidized, then this one got reduced. So when you write it, you need to write it fully because there's one here, Cu, without a 2 plus. So you cannot just say Cu. That's wrong. It means you're selecting this one. So that can't be right. It's Cu2 plus. It's the substance that got reduced called oxidizing agent. Another example. 0 being free element, and in a compound it has a positive 1 because it's in group 1. I don't have to look at the second one, but if you insist, that's a 0 and the Cl is negative 1. So Cl dropped and A increased. So the substance oxidized is an A and it is called a reducing agent. The substance reduced is Cl2 and it's called oxidizing agent. I hope that this part is clear. Which of the following is true about oxidation? So oxidation, again, it's the loss of electrons, loss of hydrogen, gain of oxygen. So, wait, did I say something wrong? Gain of oxygen, correct? Loss of electrons and loss of hydrogen. So, loss of electrons is correct, loss of hydrogen is correct. Oh, I don't have this option. Ah, here. Okay. 1, 2, and 3. That's the correct answer. Okay, so the right answer, 1, 2, and 3. It shows an increase in the oxidation number, not a decrease. Okay, next. Which of the following is true about a redox reaction? So a redox reaction, it's an overall reduction and oxidation reaction. It involves a reduction and an oxidation. Charge is conserved, yes, because when I have a redox reaction, for example, the one that was given here, an A plus Cl2 gives NaCl, even if it's balanced. Overall 0, overall 0, overall 0. Charge is conserved. I'm going to give you another example. The Cu2 plus Zn giving Zn2 plus Cu, the previous example. Overall here is 2 plus and 0, so 2 plus. Overall here is 2 plus and 0, so 2 plus. Charge is conserved. So you have to, and this is something that we're going to need in the next lesson. So charge is conserved. It has nothing to do with mass. Oxidizing agent is the one getting reduced. Correct. Okay. 1 and 3. Why I have so much mistakes in the choices? Refer to the following reactions to answer questions 3 and 5. Aluminium, that's electron added before, that's a reduction. That's an oxidation. That's a redox. That's a redox. For certain, I can know because simply by looking at O, I know that there's a change in the oxidation number. So definitely there's an oxidation and reduction involved. This one, it's not a redox. Why? Because Mg positive 2, still positive 2. And Cl, there's a negative on it. And in this compound, it's going to be negative if you find it. So an example of reduction half reaction is A. Example of oxidation half reaction is B. The equation that represents a balanced redox. Redox is C and D. Now D is not balanced. I have 4 hydrogens. I have 2 hydrogen. I have 2 oxygen here, and here I have 3. So D needs balancing. C is balanced. Which of the following is true about?
Miss,
Yes.
Miss, I didn't get why E is not a redox.
Yeah. Let's do it. What's the oxidation number of Mg? 2 plus. In here, it's the charge written on it. What's the oxidation number of Cl minus? It is minus. Okay. Now, Mg in compound. What's the oxidation number of Mg in compound being in group 2? Still positive 2. Now, Cl is X. So 2 and 2x equals 0. X is negative 1. Where is the change? Is there a
There's
change
no
in the
change.
oxidation? ما في change. Not a redox. Okay?
Okay.
Not a redox. The others are very clear. يعني أنا by looking at this and O in a compound, خلاص, it's clear. There's a change. I don't have to look for the other change. Definitely there will be another one. Consider the following, and this is a question that gave it to you in a classwork. Many did mistakes in it. Let's think about it. X is losing electrons to Y. X lost electrons. X got oxidized. X is a reducing agent. We are saying that X got oxidized, so the oxidation number of X will increase because that's the rule. Once a substance undergoes an oxidation, the oxidation number will increase. Now let's talk about Y. Y gained electron. Y got reduced. Y will be called an oxidizing agent, and because Y got reduced, the oxidation number will decrease. These are basic concepts that never change. So they want to know about X. X is oxidized. X loses 1 electron. Okay? But I wrote all the possible information about it. So it is just 2. Here. It's here. The oxidation number of Y. Y was reduced. So the oxidation number will decrease and it is reduced. Are there questions for this one? Which of the following represents a reduction half? So, reduction, oxidation, redox, redox, clear. 0 plus 2. It's a redox. But they're not looking for the redox, they're looking for the reduction. So electrons are written before the arrow. Reduction, not a redox for the same reasons of this one, this example. So not a redox. K was positive, still positive, no change. This is an oxidation, and this is a redox. Now, oxidation or reduction. Be careful to these questions. Electron are written before the arrow. Involves reduction. So reduction it's a gain of electrons. And electrons written after the arrow, it's an oxidation. You say electrons are lost. Electrons are lost. Moving on. Okay. Here we come to a bit harder part where we need to balance an oxidation reduction reaction in acidic or basic medium. There's a video that I also shared with you that explains in detail how to do the balancing, and I insist on watching it for the quiz next week. So let's first start in acidic medium. All the steps are the same for acidic and basic, except one additional step at the end for basic. Okay, so let's begin. First, you split the equation in two. What gives what? So I'm going to start with the easy one. Remember that in the exam and the quiz, there's always one half equation easy and one half equation complicated. So Fe2 plus giving Fe3 plus. First, we check if the atoms are balanced. One Fe, one Fe. Next, we balance O, but there's no O. We balance H, there's no H. We move on to balancing electrons. We balance the charge by adding electrons on the side that have a higher charge. What does that mean? The charge over here is positive 3, and over here it's 2. So here it is higher. So you count the charges and you add electrons to the side of higher charge because you want to make it equal with the one that is less. So how many electrons I need to add for 3 to drop to 2? I need to add 1 electron. And we're done. The first equation finished. Next, NO3 minus 2H NO2. You have to do the balancing in the order. You cannot miss a step. You cannot put a step before the other one. So first we start balancing atoms other than H and O. So 1N, 1N, N is good. Then you balance the atoms, you balance the O by adding H2O on the side that needs O. يعني here I have oxygen 3 and I have 2. So here I am missing one more oxygen. So I add H2O to balance the oxygen. And I just add one because I only need one O. One O more. Now it's the time to balance the hydrogens. I have 1, 2, 3. I have 3 hydrogens on this side. So I balance hydrogen by adding H plus on the side that missing hydrogen. 3 H plus. Now N is balanced, O is balanced, H is balanced. Now it's the time to balance the charges. And here I have 1 minus and 3 pluses. Don't forget the 3. 3 pluses and 1 minus. So 3 pluses and 1 minus. So the overall charge is positive 2 on this side. Whereas here, neutral, neutral, 0. So 2 plus is the higher side of the charge. So I need to add electrons to drop the 2 to 0. So I add 2 electrons. Now, Having here 1 electron, having here 2, I simply need to multiply this by 2 and add both of them. So 2Fe2 plus, and the 2 electrons will cancel out. NO3 minus 3H plus, Fe3 plus, HNO2 and H2O. Done. It is balanced. That's
Miss,
it.
you didn't. Oh, okay.
I'm going to give another example. One more example. Okay? And here, let me just fix this one. MnO4, IO3 minus, I minus.
Miss, you should add 2 Fe3 plus.
Oh, yes, yes. 2. Correct. You are right here. So let me go back to the green. 2. Yeah. If I count the charges here, I'll find 2 times 2, that's a 4 plus. That's a 1 minus. And that's a 3 plus. So the total is 6 plus on this side. And here, 6 plus. Like that, you can double check if you did it right or wrong. Another example. Balance. Okay, so I'm gonna split it. This is an acidic medium. I minus, IO3 negative. So first I count the atoms. 1I, 1I. Done. Then I balanced O by adding H2O. So I have here 3 oxygen. So I am going to add 3 H2O. I balance the O by adding H2O as much as I need. Now, I count the hydrogens. I have 6 hydrogens on this side. So here I balance hydrogens by adding H plus. Now it's the time to balance the charges. So you count. On this side, that's the only charge available. And on this side, there's 1 minus, and there are 6 pluses. So 1 minus, 1, 2, 3, 4, 5, 6. So it is 5 plus on this side. So minus 1 and 5 plus. Where is the side that is higher in charge? Here. You need to add electrons here to drop the 5 to minus 1. So if I add 5 electrons, the charge will drop to 0. But if I add 1 more electron, the charge will drop to negative 1. So 6 electrons to add. I hope that this is clear. Now this one is done. The next one, MnO4 minus MnO2. 1 Mn, 1 Mn. Mn is balanced. 2 oxygen, 4 oxygen. So this side needs more O. So I'm going to add 2 more H2O to balance the O. Now I have 4 oxygen. But now also I have 4 hydrogens. So in order to balance the hydrogens, we add H plus. Don't forget the plus. Now, it's time to look at the charges. I have 1 minus and I have 4 pluses. So the overall charge is a 3 plus on this side and a 0. Both of them are neutral. So 3 is the higher side. So you add 3 electrons to drop the 3 plus to 0. Now, 6 electrons lost, 3 electrons gained. We multiply this equation by 2 and we add both of them. So I minus, of course, you do not forget those aqueous and gas and liquid states. This is something that always you should remember to put it. So, and 3H2O and 2MnO4 minus and 8H plus, giving IO3 minus and 6H plus and 2MnO2 and 4H2O. So I was multiplying every single one here by 2. Now, before we continue, 6H plus and H plus 8, 2 remains. 4H2O and 3H2O, 1 remain over here. So let's write it again. I minus plus 2MnO4 minus and 2H plus IO3 negative 2MnO2 and H2O. Now let's focus on making this basic medium. How do I make it basic medium? And here comes the additional step. You focus on the H plus. Let me remove the highlight. It's annoying. So here's the H plus. How much H plus you have? You have 2. So you add 2 OH minus on each side. So the rule is as follow. You go count how many H plus you have and you add OH minus as much as H plus available on the equation. But in order not to disturb the balancing of atoms and the balancing of charges, whatever you do on one side, you have to do it on the other side. So 2OH minus, 2OH minus. Now, we know that every H plus added to OH minus, that makes an H2O molecule. So you copy again this one, I minus, 2MnO4 minus, plus 2H2O, giving IO3 minus, 2MnO2, H2O, and 2OH minus. By seeing this OH minus on the equation, I now know that this one is in basic medium, and I got rid of the H plus that was present. Now, last look, I have here 2H2O, and I have here 1H2O. So you rewrite this equation, and you cancel the H2O. You keep only 1. So that's the final answer.
Yes, why didn't you write if it's aqueous or solid or liquid?
I was going to do it now. The last step, instead of doing it in all the steps, I'm just going to do it in the last one. Okay? Anything charged is aqueous. NO2, I think, let me just double check. Usually these are given. It's solid. These one are given to you. Now, again, I repeat, in the other video of balancing redox equations, you need to watch it. There are more examples and similar to the quiz that is coming. Next, we continue. Please. So the two types of electrochemical cell shown below are voltaic and electrolytic cells. So identify the cell that best fit each of the following. So electrolytic cell, okay. So these two are electrochemical cells. However, one is spontaneous, the voltaic cell, also known as galvanic. and one is non-spontaneous. One converts electric energy to chemical, and one the opposite. It's a chemical reaction that produces electrical current. So chemical to electrical energy. Also, there are differences between the electrodes of the electrolytic and voltaic cell. In the electrolytic cell, the electrode, the cathode is the negative and the anode is the positive. Whereas in the voltaic cell, the cathode is the positive and anode is the negative. The rest is the same. Okay, yani I mean, at the anode, there's always an oxidation. At the cathode, there's always a reduction. So a spontaneous voltaic, one of its component is a battery. The voltaic cell require electric current, the electrolytic cell requires the presence of a battery to start and initiate a chemical reaction. So it's the electrolytic cell. The anode is the positive. It's in the electrolytic cell. And chemical energy is converted to electrical in the voltaic or also known galvanic cell. Consider the following voltaic galvanic cell that operates spontaneously. So I know that this is voltaic. They've told me that it is spontaneous, chemical to electrical. Before you read any question, you have to look at the diagram to find the signs. And give me 1 second. Okay, I'm going to explain it over here. In a voltaic cell, the cathode is the positive, the anode is the negative. On the cathode, there's always a reduction taking place where the ion in the solution gain electron to convert to solid. Gain of electrons. But in the anode, at the anode, it's the one that undergoes an oxidation, and it's the metal of the anode that loses electron to give the more ions in the solution. So it's a loss of electrons. So think about it this way. It's the metal that starts, it's more reactive. Zn will be more reactive compared to silver metal. It's the one that's going to lose electrons. Therefore, the electrons will start flowing from anode to cathode. And the zinc, when it loses electrons, it turns to Zn2 plus. So more Zn2 plus are going to accumulate inside the solution because the metal is losing electrons and forming more and more ions. On the other hand, when the electron reaches the cathode, it's the silver that are in the solution. They catch the electrons and they give more silver metal. So previously we have a lot of zinc, a lot of silver ions along with a lot of negative ions. So let's say this solution is AgNO3. So I have a lot of NO3 minus. I'm going to write with a different color. So I have a lot of Ag plus inside in here, ions, with a lot of negative ions coming from the solution of Ag nitrate, silver nitrate. However, when the electron arrives, every Ag plus will catch an electron and give Ag solid. So the amount of positive ions is reduced, becomes less. Therefore, so it is consumed. Meanwhile, what happens inside the salt bridge? To maintain the balance a balanced cell, or the ion neutrality in the cell, to maintain the neutrality of the cell, the salt bridge will send positive ions to this side, since we consumed all the positive ions of silver plus, to maintain the neutrality between these ions. And on the other hand, because there's a lot of positive ions produced on this side, the salt bridge will send negative ions to balance the Zn2 minus formed. Like this, the salt bridge will maintain the cell neutrality. Also, one more thing, electrons flow from anode to cathode. They go from anode to cathode, and when this cell operates, there's a current that's going to flow from cathode to anode. An important thing we always ask our students, where the electrons flow, through what? Electrons, they flow through the electric circuit, whereas electron and current, whereas the ions, they flow through the salt bridge. So don't get confused in this. So the more reactive metal is the one that's going to start the oxidation at the anode. The equipment X is known as salt bridge. The spontaneous reaction in the voltaic cell involves oxidation and reduction. So it's a reduction, redox, the oxidation, redox. Electron, they flow from anode to cathode. K plus, they go toward the cathode. Be careful. When you are talking about electrodes, it's always a metal. So zinc and Ag. Never zinc 2 plus and Ag plus. You can never mention the ion if you're talking about electrodes. Now the cell notation. The cell notation, it's the anode separated by a salt bridge from the cathode. And in the anode, it's the zinc that is changing to solution. And when the electron reaches the cathode, it's the silver that is catching those electrons to give silver solid. So it's like that. Right, the oxidation half reaction, it's the one over here. It's the Zn going to Zn 2 plus and 2 electrons. And the reduction, it's the silver changing into silver solid plus electron. I've posted a video also on my channel that explains in detail the galvanic cell. I really insist on watching it. Now write the overall. When I look at this one, there's 2 electrons, there's 1 electron, so I need to multiply this by 2. And the overall equation is Zn solid plus 2 silver ions, giving Zn ion and 2 silver solids.
Miss,
Yes.
for the question that says K plus migrate towards the, can't I say the AG solution?
Yes, you can. Because you mentioned solution. So it's going toward the solution of Ag plus. Say Ag plus solution. Or you can say towards the cathode. Okay?
Okay.
So in this case, yes, you can. بس شوفي أنا I wrote cathode, so I had to write Ag. But if you want to write solution, you have to write Ag plus. Okay?
Okay.
Now, last question. Uh, calculate the E cell of the above voltaic cell. So the E cell formula is the cathode minus the E anode, and most probably this formula will not be given. يمكن I'm just assuming. but because before they never give it. So since we said that Ag is the cathode, so it is 0.80 minus the anode. And the answer is 1.5 volt. That's the E cell. One more information, E cell being positive means another indication that this is really a spontaneous cell. Again, another question. Here's the anode, I knew it from the sign. And here's the cathode. Okay, oxidation occurs at the anode. You choose Z at the anode. And reduction occurs at the cathode, but there's no question for that. Oh yeah, I forgot to mention this. Anode loses electrons, undergoes oxidation, negative ions migrate to it, and loses mass, reduces in mass. Cathode, gain electrons, there's a reduction, positive ions migrate to it, and gain mass, increase in mass. Yani this after a while becomes large and this will disappear. Okay, so increase in mass, it's the cathode, it's the Y. Electron flow through wire T, electric wire. The structure maintains solution electron neutrality, it's the salt bridge. The electrode that has the most reactive metal, it's the one that gets oxidized. It's the metal Y that starts oxidizing. Sorry, here. It's the metal Z that starts oxidizing, undergoing oxidation and losing electrons. So Z is more reactive than Y. And it contains oxidizing agent. It means it's the one that gets reduced at the, at the cathode. Wait. Why is the oxidizing agent? Is the wait. Let me just clarify this one because I answered wrong. So here I have the ions in this solution that are going to get reduced in order to give me more Y metal. So the ions are the oxidizing agent, and the one that contains these ions is U. Now it's right. Okay, and in the previous example, if I'm going to show it to you on the figure, the one that undergoes reduction is the zinc, is the silver. So silver ion is an oxidizing agent getting reduced at the cathode. So that question in the next one, it was asking me, it contains the oxidizing agent. So the cathode half cell, which is U solution, contain the oxidizing agent, which are the ions. I hope that it is clear. Is it? Okay. Now, last question. Yes, last question in this revision sheet. Consider the following galvanic cell. I know that it is a galvanic, but I don't know which one is the anode, which one is the cathode. There are no indications on the migrations of ions. There are no indications on the electrodes, whether it's positive or negative. And they're not showing me the flow of electrons, so I can't tell. In this case, I need to rely on the reduction potential. The reduction potential, so here we go. Al3 plus and Mg2 plus, we are looking at them right now as they are oxidizing agent. However, Al3 plus is a stronger oxidizing agent, and therefore this is the one that's going to play the role of the cathode, and this is the one that's going to play the role of the anode. So Al3 plus is at the cathode and Mg2 plus is at the anode. Why? Because it's the stronger oxidizing agent. However, in class I mentioned you compare the numbers. The one that is having a higher voltage is the cathode, and the one that's having the lower voltage is the anode. So that's the anode and that's the cathode. Identify the anode. So you say Mg and not Mg2 plus. That's wrong. Okay. Identify the electrode that increases in mass. It's the one that gain electron. It's the one that undergoes reduction. So it's aluminum and not Al3 plus. You cannot say Al3 plus. Next question. Identify the electrode where oxidation occurs. It occurs at the anode, which is in this case Mg. On the diagram, by the way, this is a question that was given in an end of year exam. Indicate the direction of electron flow. Electrons, they go from anode to cathode. So electron flow. And calculate the E cell. It's E anode minus E cathode. I'm going to do it here, part E. E cell. Oof, I said it wrong. E cathode minus E anode. So it is negative 1.66, negative 2.37. So the answer is 0.71 volt. Last question. The salt bridge is filled with KBr solution. Yani it's filled with K plus and Br minus. On the diagram, indicate where Br minus migrate. I'm going to do both. To the cathode, that is positive electrode, migrates the positive ions. To the anode, that is negative, migrates the negative ions. And that's it. So you can put a direction, Cl minus or Br minus. It's Br minus, sorry. Yeah, but it's the same, yani. No problem. So Br minus. Okay. And that's it. Any questions? Questions, ladies?